half of the term. Tonight we are hosting Iain Chalmers. He's a British health researcher, one of the founders of the Cochrane Collaboration, and now he's a coordinator of James Lind initiative. Tonight he will be talking about reducing waste in deciding what research to do. So please join me in welcoming Mr. Chalmers tonight.
Thank you very much, Jakub, and thank you for the invitation to come and speak to you. Leon said, what's the James Lind? Who is James Lind? And I hadn't thought of actually explaining who James Lind was, but perhaps in the light of his question, I ought to try and answer that, because the James Lind initiative has the grand total of 2 people working in it. There's me and my administrator colleague. And what we have done is worked for 10 years now with others, it hasn't been just us, to try and get people to admit uncertainties about the effects of treatments. And then obviously the research that should address those uncertainties. The reason being that when there are examples, quite a lot of them, that when people haven't addressed uncertainties about treatment, people have suffered and died unnecessarily. Now, James Lind was uncertain. He was a Scottish naval surgeon in the first half of the 18th century, and he was confused by the fact that there was uncertainty about how to treat a disease which was killing a lot of sailors, scurvy. We now know it to be due to vitamin C deficiency, but that wasn't known at that time. And there were various views about how to treat this condition. And, for example, the Royal College of Physicians recommended sulfuric acid. So what he did was, to cope with this uncertainty, he set up a controlled trial of 6 different treatments, and you'll predict that the oranges and lemons that he gave to that group won hands down. The sailors with scurvy recovered very fast and were able, in fact, to nurse the still beleaguered sailors that were still suffering from the disease. So that's the person after whom the initiative has been named, and I hope it gives you some idea of what my interests are. As someone who started off as a clinician and found out, to my horror, that some of the things that I had been taught to do in medical school were actually resulting in suffering and sometimes deaths of my patients, I started to have what became a chronic skepticemia. Any person who shared their opinions about the effects of treatment wouldn't be taken seriously unless they could start to produce evidence to show that their opinion actually was based on good science and not just on hunch. So that's the background to the sort of person I am and what the James Lind Initiative is about. The talk I'm going to give is, in fact, the first of 5 sections, each of which will be covered in a series of articles coming out in the Lancet on the 8th of... the Lancet, for those of you who don't know, is a medical journal, comes out every week. And they will be published almost certainly on the 8th of January. And this is the first talk that I've given drawing on material which is based on the final version of the paper that I'm the lead author for, which has now gone into the Lancet. So it's in the pipeline now, and it's on the way to print. So I'm very interested in what you've got to say, because at the page proof stage, if I've made some blunders which are obvious to you, there may be an opportunity to correct them. So, back in 2009, a colleague, Paul Glasziou, who's a general practitioner, is an Australian general practitioner. By the way, am I speaking loud enough for you to hear me up at the back? Is that all right? Australian general practitioner who was, for I think 7 years, the director of the Centre for Evidence-Based Medicine in Oxford University. And we wrote a paper about, as you see, avoidable waste in the production and reporting of research evidence. And you'll see there the four sources of waste that we considered. And we came to the conclusion that about 85% of a very large number of pounds or dollars were being wasted, which is a pretty shocking estimate. It wasn't challenged in the correspondence columns. Clearly it's open to challenge, but if you're going to challenge it, you need to come up with better evidence. And there are certain characteristics of medical research which suggest that a very large proportion of investment in medical research is wasted. Not because you get disappointing results, particularly. You expect that in science. That's how science works. By starting off with an idea where you want to estimate a probability or test a hypothesis, and sometimes it works out that the hypothesis is confirmed, sometimes it doesn't. But as I say, that's the way that science works. So it's not that sort of waste, and I hope to show you what it is. Now, in our publication, we identified 4 different sources of waste, which are listed there. But in fact, some criticism of our paper suggested that we'd missed out an important one. It's the one in the middle there. Basically, inefficient research regulation, in fact, hyper-regulation of research, and inefficient delivery of research. And we hadn't covered that in ours. And so the series that will be published in the Lancet are now going to cover those 5 sources of waste. And I'm going to talk about that one, the very first one. That's the one I'm lead author for. And here are my co-authors. I'll just give you a moment to look through them. They've been a fantastic bunch to work with. So just to make the point, they include basic scientists, people who work with animals almost completely. They include a social scientist, a couple of epidemiologists, a bibliometrician, a clinical pharmacologist, an oncologist, someone who treats people with cancer. That's Benjil Begovic. So it's quite a mixture of people, and it reflects the effort that this series has made to cover preclinical, basic research, applied research, if you like, and epidemiological research. And these are the things that I'm going to try and cover in the talk that I'm going to give. I want to talk about how, first of all, what scheme we adopted to categorize research. Then I want to talk about the relative investment in basic and applied research. I want to draw attention to the different sort of research that gets done depending on whether you run as a funder a responsive way of funding, that you basically receive the proposals from researchers, or whether in fact you want to intervene and try and commission research which you have come to a view is needed. Then I want to concentrate on 2 particular sources of waste. One is by ignoring what the potential users of research results want, and the other by ignoring what's already known or already in the process of being researched. So let's start with that one. A man called Stokes, an American, in 1997, came out with a book, in fact it was, called Pasteur's Quadrant. And what he had done was to categorize research about whether it was relevant for immediate application on one dimension or for advancing knowledge without any concern about whether it would be the results would be applicable. And Pasteur is in that quadrant up there on the top right because he was an example of use-inspired basic research. his research on infectious diseases was prompted by both human and animal infectious diseases and the economic effects actually on the silk industry because of infections in silkworms. So he was very much involved in trying to find solutions to these issues that people were coping with. Stokes, in his original paper, had Niels Bohr in the pure basic research, the physicist. And we've replaced him by Marie Curie, because she was concerned by the challenge of science. She wasn't, and made it very explicit, she wasn't, although it did end up having implications for treatment of disease, that was not why she was doing the research that she wanted to do. And we replaced what Stokes had as Edison, who invented the light bulb. It was a very straightforward example of pure applied research by Richard Doll, who together with Austin Bradford Hill successfully identified a major cause of the epidemic of lung cancer, which was happening during the 1930s and 1940s. And then we've labeled that fourth quadrant as the waste quadrant. I mean, there's waste in these other ones too, but if research is neither much good for advancing knowledge or for immediate application, then how on earth does it get to be funded and done, wasting people's time if nothing else? So here's an example of, a modern example of the dividends of pure basic research. Akira Endo was a biochemist who was interested in the relationship between fungi and cholesterol biosynthesis. And it was that basic research which led to the development of statin drugs, which many of you will know about. They reduce cholesterol. Here's an example of the dividends of pure applied research. Ian Roberts at the London School of Hygiene and his colleagues addressed the uncertainty, the clinical uncertainty about whether giving systemic steroids to people with acute traumatic brain injury was a good idea. I'll come back to that example in a moment. And then here's an example of the dividends of use-inspired basic research. Malcolm MacLeod and his colleagues, first of all, did a systematic review of the effects of a large number of drugs in experimental autoimmune encephalitis in rodents as a model for multiple sclerosis. And they identified 3 off-patent drugs. I mention that because it would be of no interest to industry to study these things, that they deemed worthy of assessment in people with primary progressive multiple sclerosis, which is the form of multiple sclerosis which tends to have been ignored by the research community. And those trials have now been funded, and they're going forward. What about the relative investment in basic and applied research? Well, in this country, we've had 2 surveys, 2006 and 2010, of that investment as it relates to public and charitable funds. And as you'll see, pure basic research gets the lion's share of the total spend on research. It's fallen a bit. I'll come back to that in a moment. But basically, it's still well over half of the total funding goes to basic research. Then you've got pure applied research. That's gone up a little bit. And then use-led basic research, which is the smallest category. Again, it's gone up a bit, but it's only about 10% or 12% of total spend. Now, the reason for that, the sort of history behind that ratio, goes back to a paper published in Science in 1976 by these 2 people. Julius Comro was a physiologist, particularly interested in the physiology of the heart. Robert Dripps was an anesthetist in Pennsylvania who actually died 3 years before this paper was published. And basically, it has misled people for a very long time, this paper. Probably still does. They claimed that 62% of all articles judged essential for later clinical advances resulted from basic research. Their conclusion and methods were challenged at the time, for example, by Richard Smith, who was editor of the BMJ at that time, and an attempted replication of their analysis found that it was not repeatable, reliable, or valid, and that only between 2 and 21% of research underpinning clinical advances could be described as basic. But I would say that the paper was extremely important in having the effect on the funding ratio that I showed in that table. Now, obviously, I want us to look at the health dividends from basic research, but it's really quite difficult to do. And it's mostly in terms of anecdotes. There's not much formal evaluation. And certainly what's around is not all that strong. And you can't even really come to a conclusion about what would represent a reasonable yield from basic research in terms of later advances for health, like Akira Ender's, for example, on cholesterol lowering. Furthermore, most initially promising findings turn out to have been false positives or exaggerated. And here's some recent bibliometric analyses to support that last statement. Kontopoulos Ioannidis and her colleagues, including her husband, John Ioannidis, looked at over 25,000 papers published in the 6 leading basic science journals between 79 and 83. 101 of those articles made confident claims that new discoveries had clear clinical potential, yet only 5 of those 101 had resulted in interventions with licensed clinical use by 2003, and only 1 had resulted in extensive clinical use. Here's some others done by RAND Europe, evaluating translation from bench to bedside, found that it is in fact applied clinical research, not basic research, which results in greater health, social and economic impacts. And they've done that for 3 areas: arthritis research, cardiovascular research, and mental health research. And the same message comes across from all of them. They're quite resource intensive, these studies, because you can imagine it's quite difficult to do all of the tracking that's necessary to find out what actually did lead to what. So their conclusions of the most recent one, which was on mental health research over the past 20 years, is that it has certainly resulted in important advances, but clinical research has had a larger impact on patient care than the more basic research. That those involved in mental health research who work across boundaries, that's the Pasteur's quadrant, use-inspired basic research, are associated with wider health and social benefits. And they make the point that committed individuals, individuals who are motivated by patient need, who champion research, are associated with better outcomes. Now, there has been concern in this country and in other countries as well, because this ratio of funding for basic and applied research, it's not just in this country, it applies in many countries. Certainly it applies in the United States where it's been quantified, but it applies in many countries. Just a matter of interest, in terms of that characterization, could all of those people who regard themselves as basic researchers put their hand up? What about applied research? Right. Okay. So the basic researchers have stayed away, Roy. Why is that? Basically, there was a problem that was recognized by a paper that we published in the BMJ, which showed that in the late 90s and early part of the noughties, there had been a decline in publicly funded controlled trials. And the preclinical researchers were worried because they were having important ideas they thought were promising ideas, and basically there wasn't the infrastructure, there weren't the people trained in doing clinical trials, there weren't the facilities or the infrastructure that had been allowed to, if you like, rot. And so they weren't able to actually embark on the sort of translational element from the preclinical research to find out whether their hoped for treatment advances were actually borne out in clinical trials. And there were two inquiries at the time, one by the Academy of Medical Sciences, the other by the Department of Trade and Industry, chaired by a man called David Cooksey, a venture capitalist, in fact. And both of them, amongst other things, looked at these data and said something needs to be done about that. So what happened was David Cooksey wrote a report in 2006, and that his recommendations are almost certainly the principal reason for that shift in the direction of applied research, which has happened since 2006. What about responsive versus commissioning funding of biomedical research? Well, in basic research, you're looking for people who've got sometimes wild, wacky ideas who should be allowed to pursue them. And yet the peer review system operates against wacky people. It's conservative, basically. And if something is being proposed which is wacky but probably interesting, people who are on the grant-giving bodies won't recognize the sort of thing which they think is important and the sort of way of going about it. So how to fund basic research in a way that it yields more dividends remains really quite mysterious. And there needs to be more science of science, research on research, to try and find out what a winner looks like relatively early in its career, you know, after 5 or 10 years. But if you look at responsive versus commissioning funding for applied research, basically it really, in the same paper that we published in 2003, what you'll see there is if you look at the orange and fawn, would it be beige columns, which are the Medical Research Council and the research charities, you'll find they're all bunched up towards the drug end of research. It's basically the NHS and its equivalents, well, the NHS in Scotland, England, and Wales, that is funding stuff not just to do with drugs, occasionally radiotherapy or surgery, and that's a reflection of cancer in particular. But they're funding trials not only on surgery, but on education and training, service delivery, psychological therapies, devices, social care, across the board. And this pattern reflects the difference between a responsive system of funding, where it's the researchers pitch their ideas to the funding agency and see whether they can win the competition for funds, and a commissioned research program where people are saying, for example, look, there's a whole lot of physiotherapists in the country. We don't have the evidence base to show which elements of physiotherapy are really useful. Physiotherapy research is very difficult by comparison with drug research. But we want this research and we want to make it available. So they then go out and they commission bids. They invite bids for research to look at aspects of physiotherapy. So it's the two funding patterns result in a very different pattern of funding. Now, this little baby has leukemia. And one of the things that's astonishing about leukemia is that when I was at medical school in the early 60s, it was a death sentence. People didn't survive. However, the community of pediatric oncologists, the hematologists who were responsible for treating these children, got together and they decided that all new cases, as far as possible, of leukemia should be treated within the context of a controlled trial, comparing a new idea with an existing idea to see whether it in fact represented an advance. So now, 80% survival is expected. It's a dramatic change associated with lots of things, but certainly associated with a very coordinated research program which deals with the problem in really a scientific way. That's the best way to put it. What's the prior probability of a proposed new treatment being superior to established treatments? Anyone want to guess? 70%. You think that, you've given me a percentage, but what are you saying? You think it's 70% more likely that a new treatment will be better than an existing treatment. Is that right? Is that how I interpret you? Yeah, well, actually across the board, yeah. You can do it if you start with trial cohorts which have been registered before the results are known, then you can apply it, you do the analysis on published and unpublished results. Well, it's actually very slightly more than 50-50. We published this paper in Nature about 2 months ago, and it's based on, as you see, getting on for 900 controlled trials, published and unpublished, phase 3 trials, involving a very large number of participants. And the likelihood of a new treatment being better in terms of morbidity, that's non-mortal disease at that point, or mortality, as you see, it's almost beautifully symmetrical. It's just a little bit shifted to one side. And that's based on 6 different cohorts of trials. It's only a 2-page paper because it summarizes a Cochrane review which has much more detail of the methods. But you might like to look at it because most people assume that new treatments are, a bit like you did, Roy, rather more likely than the tiny difference that it makes. And that obviously brings inappropriate optimism to the likelihood of finding large effects. These data mean that taking a particular trial, your chances of actually predicting whether it'll turn out the new treatment will be better or worse, you're on a hiding to nothing. So that's why I said earlier on in the talk, doing these trials, you'll sometimes be disappointed that what you thought was an important new treatment turns out not to be better than what you've got already. But that's exactly what controlled trials are for. If you knew that a treatment was better, if it had a very dramatic effect, very occasionally medical treatments do, then you wouldn't be doing the trial, or you certainly wouldn't be doing a randomized trial, because you'd be denying people treatments that you believed to be superior to alternatives. So this is the way in which that trial unpredictability yields predictable therapy gains, like the leukemia example that I showed you just now. Right, now on to the 2 sources of waste that I mentioned. First one, ignoring the needs of potential users of research. Low quality, low priority questions being addressed and important outcomes not assessed. Now, the users of preclinical research, of animal research, they want to know whether the animal model is actually a good one, that it produces in replications consistent results. There are reasons for thinking that it's led people towards useful treatments in medicine or diagnostic tests or whatever it is. That's what they want to have. They're the users of research, of that kind of research. Obviously, the applied researchers are interested in the quality of preclinical research, because if they're going to do the first trial on a particular agent, they want to have some reassurance that it's going to be worthwhile testing. And in general, the place they look to for that is a combination of animal research, particularly if it's a drug, or observational data, which may well be so biased that you can't actually trust it, but it as a basis for action, but nevertheless gives you a clue in a direction where you want to follow through with a well controlled trial. So here's an example of the mismatch. This is quite a famous one. Some focus groups were set up of people with osteoarthritis of the knee, physiotherapists, general practitioners, and rheumatologists. And they asked them, these 4 groups in focus groups, what research they would like to see more done on in osteoarthritis of the knee. And you see, knee replacement was something that they all were very interested to see more research on. Education and advice. How do I cope with a painful, disabling condition without going to surgery? And miscellaneous others. But then they looked at what research was actually being done on this topic, and as you see, there's a complete mismatch. The vast majority is for drugs. And that's one thing which patients and clinicians made explicit, that they actually didn't want any more research on yet another non-steroidal anti-inflammatory drug in a small sample done primarily for marketing a new analgesic. Part of the former program of the James Lind Initiative, it operated between 2003 and the end of March this year, was to create a database of uncertainties about the effects of treatments. Uncertainties being defined as situations where you couldn't currently answer the uncertainty by referring to relevant and reliable, up-to-date systematic reviews of existing research evidence, either because the reviews hadn't been done, or because they were out of date, or because the reviews themselves were reliable, up-to-date, but they confirmed that no one knew what the relative merits of the 2 things compared had been. And what that provided grist for was a prioritization process set up under the label James Lind Alliance of patients and clinicians, not researchers, but patients and clinicians getting together, sifting through these potential candidates for new research and being forced, actually, to come to a top 10 list of priorities. And that's the sort of system we were looking at. You harvest your uncertainties from systematic reviews, from clinical guidelines, from surveys of patients, from surveys of clinicians, and then you get rid of the ones that actually aren't uncertainties, because people didn't know that there was an answer to the question which they thought hadn't been answered. Then you work out which ones are actually driving at the same question, but have used slightly different wording, so you get what we called indicative uncertainties then. And then you agree a long list, and you get a short list, and you get a face-to-face meeting using something called the nominal group technique to try and find out where there will be an agreement on the top 10. And these are all of the priority setting partnership figures totaled from all of the priority setting partnerships when this slide was made. And you then you lobby for high priority uncertainties to go to research funders. And it's been very heartening the extent to which the funders have actually responded to those prioritized uncertainties. And what you find is that you get a pattern which reflects what I showed you in that earlier trial, comparing the amount of drug studies being done on osteoarthritis of the knee and people's wish not to have more drug studies. What you find is that if you compare these patient-clinician priority setting partnerships and what types of interventions they want to see evaluated, they want to see more evaluation of education and training, service delivery, psychological, physical interventions, exercise, complementary therapies, diet, self-treatment is another one. Whereas if you look at the controlled trials that are being done at the time that these workshops were happening, the partnerships were happening, you find that the pattern is very different again. So the most extreme example is the registered commercial trials, where it's not surprising that drugs and biologicals should be a vast majority of those. What is surprising, and it would have appeared if it was the case, is you don't get those interventions, the drugs, compared with non-drug interventions much. So you don't get, for example, a new antidepressant drug compared with cognitive behavioral therapy. It's an example of a non-drug intervention. They tend to be either drug-drug comparisons or drug-placebo comparisons. And then the non-commercial trials fall somewhere in the middle. The other problem is that important outcomes aren't assessed in many of the trials that are done, many of the applied trials that are done. So, drawing from the experience of those priority setting partnerships, people are interested in long-term effects which haven't been sufficiently studied, both good long-term effects and bad effects. They're worried about safety and adverse effects of treatments. And as you see, they're interested in things including self-care. People would like to be able to help themselves, but they want to know that their efforts to help themselves would be worthwhile. So one thing that came out of the asthma priority setting partnership is both clinicians and patients felt that they wanted to know whether breathing exercises were any good in reducing your risk of having an exacerbation of asthma. It's an important question. Absolutely not on the radar of asthma researchers at all. Bubbled up to the top. Now it is being studied in a randomized trial to see whether it's worthwhile doing these exercises or whether it's actually doesn't have any impact or measurable impact on your asthma. It was a surprise to the rheumatologists who were involved in studying rheumatoid arthritis. When they started to ask patients what outcomes they thought were important, it wasn't either pain or immobility or stiffness, it was fatigue. And since that insight, trials of interventions for rheumatoid arthritis have started to look at patients' fatigue, and it is indeed a very important and horrible symptom. Now, you'll see up there outlined in red, there is an initiative called the COMET initiative, that's Core Outcome Measures in Effectiveness Trials, to try and find out what outcomes patients think are important, not just what are easy to measure because they're in blood or through some psychological scale, which is actually difficult for patients to interpret, and clinicians come to that. And that's a very encouraging initiative. Here's the first of the two references I'm going to make to Alessandro Liberati, who died on the 1st of January last year, looking more or less like that. He died very young. And in this letter to the Lancet that he wrote just before he died, he had multiple myeloma. He identified 1,400 studies. Of these, 107 were phase 2 or 3 comparative studies, that is, the later stages of trialing. However, in only 58 of these studies was overall survival an endpoint, and in only 10 of these was it the primary endpoint. No trial was a head-to-head comparison of different drugs or strategies, which he was being asked to adjudicate between. Meanwhile, experts feel that cytogenetic studies and gene expression profiling will lead to personalized treatment in myeloma, and pharmaceutical companies avoid research that might show that new and expensive drugs are no better than another comparator already on the market. So he was badly let down by the research community. In an earlier paper that he published in the BMJ, he drew attention to the unpublished trials, which he knew had been completed because abstracts had been presented at meetings, but which had never been published in full, and which were relevant to the choices that he had to make as a patient. And he felt that it was a disgrace. Quite rightly. I'm not going to go through these sort of laboriously, but basically people have looked at steps which seem sensible when you're trying to work out what health research priority setting to embark on. And they're fairly obvious things. The importance of this article by Mona Nasser and her colleagues is that she drew on about 5, I think, different analyses and recommendations and made a synthesis of what seemed to be the main points that were agreed among them. Way back in 2000, I suggested in a letter to the Lancet that rather than the same way that there's a good food guide, there ought to be a good controlled trials guide. That patients should be invited to have a look at protocols for controlled trials that were ongoing and decide whether they think that it would be worth their time participating in it. Did it refer to was it addressing a question, first of all, that hadn't already been addressed and answered, that it was a question relevant to them, that it looked at outcomes, that means that were relevant to them, that they had an undertaking that it would be published. As I'll show you in a minute, that's a problem. I think that we've got to get patients and clinicians making a louder noise about the mismatch between what the research community is doing and what they want. And it actually works to help studies succeed. In this study, which was published last month, the involvement of patients in study selection of the topics and study design actually led to more achievement of recruitment targets, which is a very, very big problem in clinical research. It means that trials end up being far more expensive than they need to be because they don't recruit fast enough. So last section is waste resulting from ignoring what's already known, already being researched. So that's the bottom bit. In spite of the fact that when I look at this thing on my computer, the red box is in the right place, it always seems to prolapse when it goes up on a screen. I'm sorry about that, but you get the thing. It's this business of not actually finding out what's known already before embarking on new research. And basically it's unethical. It's certainly unscientific, but it's unethical. You shouldn't embark on research if you haven't found out systematically, that means using scientific principles, what's already known. It's not fair. You've got to try and get as high a proportion of the relevant evidence as you can. Yet, when we look, as this study did, and the extent to which, in this case, randomized trials referred to relevant previous randomized controlled trials, you find that they don't refer to a very high proportion of them. And they point out that the potential implications of this scientific misconduct, because that's what it is, include ethically unjustifiable trials, wasted resources, incorrect conclusions, and unnecessary risks for trial participants. It's a disgrace, and it's a very widespread disgrace. Even in the medicine's best journals, the Lancet, the New England Journal of Medicine, the BMJ, JAMA, Annals of Internal Medicine, you'll see in the second row there that only 1 out of 29 and then 1 out of 35 reports of new trials referred to the fact that they did a systematic assessment of what was known already before embarking on their new trial. I might also add that they don't put the results of their new trial in the context of a systematic review of other relevant trials. So readers of that article will not know whether it's an outlier, whether it supports earlier research, or maybe even contradicts it. We're not well served. Here's an example. Nimodipine, a calcium antagonist in animal models of focal cerebral ischemia, stroke, basically. And as you see, the review of these animal studies done by Janneke Horn and her colleagues in the Netherlands didn't show any convincing evidence to substantiate the decision to perform trials with nimodipine in large numbers of patients. More than 7,500 patients were entered into trials of nimodipine. And there again, there was no evidence that the drug was helpful. So wonderful concordance between the animal model results and the human model results, but what on earth was happening with the people who ignored the animal evidence, never did a systematic review of it, and embarked on 46 trials of this drug? I don't know how much waste just that one example would have resulted in, but a hell of a lot. And here's a really fundamental problem, that half the trials that are done, it doesn't matter all that much whether they're early phase, later phases, commercially funded, not commercially funded, half of them don't ever get published. It's a complete and utter waste of research investment. It's a betrayal of the patients who participated in those studies. And it's a waste of resources, because not only do they not get published, the ones that do get published have got different results on average from the ones that don't get published. They tend to have more statistically significant differences found. So you're actually biasing the science of synthesizing the results of these studies to try and work out what this body of evidence, whatever it is, actually shows. It's not the case that all research programs, if you take the UK Health Technology Assessment Programme, 98% of their studies are published. So it's not that it can't be done, and it's not about journals rejecting submitted papers, it's people not submitting. Either because sponsors don't like the results, researchers can't be bothered. There's not enough research being done actually on the reasons that this poor publication record is the way that it is, but it's a disgrace. I mean, one of the things that the HTA program does is it actually withholds 10 or 15% of the grant until a paper has been submitted for publication. Some of you may have heard about this book, some of you may have read it. It's very important. I've been wittering on about publication bias for 3 decades, and my wittering hasn't made a blind bit of difference. Ben Goldacre's book has really shaken people up. And for the first time, you see academia and the industry, the drug industry, on the back foot. They're really fighting to try and maintain the status quo where that is accepted. It's a disgrace. It really is betraying the interests of patients and the public. If you haven't already signed up to www.alltrials.net, please go there, add your signature, so you can be among the, I think it's got up to 60,000 signatures now, with quite a lot of important organizations, the Medical Research Council, GlaxoSmithKline, for example, also signing up as institutions to the idea that all trials should be registered and all trials published. Now, one of the ways in which we can see the damage of this failure to do systematic reviews of, systematic reviews of existing evidence before embarking on a new piece of research is by doing retrospective cumulative meta-analyses which demonstrate waste. So here's one which is looking at the effect on tissoplasminogen activator in animal studies of thrombotic occlusion models of stroke. So what you can see there is that the earliest trials were done at the end of the 1980s, and then more and more trials were done, but they kept on being done. What were the animal researchers thinking they were doing? Repeating this thing again and again and again, in spite of the fact there was a really secure answer by the early 90s. Did they like putting animals into studies that were going to show the same result as the previous, whatever it is, 90 trials? Complete waste. What about clinical research? This is looking at the effects of antenatal corticosteroids on risk of neonatal death, an example of pure applied research. And what you've got there is the first trial, published in 1972 in the journal Pediatrics, which shows a statistically significant advantage in terms of death of corticosteroids compared with placebo. And then as more and more trials, and that's, as I say, gives already a pretty clear result, but you should always replicate to try and find out whether an early result is a fluke. But basically more and more trials were done. The confidence intervals of the estimates, as you added in the new data, got narrower and narrower and narrower. And that was the number by 1993. There were a few more done after that. I don't know if any of you have heard. Has any of you heard of the Cochrane Collaboration? Does that mean anything to you? Okay. So it was that series of trials that forms the basis for the logo of the Cochrane Collaboration. Because why did people go on doing these trials when the answer was clear much earlier? Here's another example. This is a drug called tranexamic acid, which was invented by two Japanese workers in the late 40s. It's very cheap. And what it does, it stops the breakdown of clots which are formed in people who are bleeding from trauma or from other things. And as you'll see, early trials were done, controlled trials were done going back quite a long way. But you'll see that there are a whole lot of trials looking at blood transfusion, which is a surrogate outcome. Maybe an important surrogate outcome, it's a surrogate outcome. And they go on and on and on addressing that question without addressing the question, does it increase your risk of having a heart attack? And what does it do to death? So all these trials in this thing, after about, 2001, complete waste. They've contributed nothing of importance. Those people should have been collaborating in global, multi-center trials to answer the questions which remain unanswered in those two columns. So I've been over this business about what I consider really gross waste in deciding what research to do. Here's an example of the way that things can be done if people do things properly. You saw this picture before. I'm just going to give you an account of how this question was addressed. So first thing to do is to find out what's known already. And the results of that review were published in both the BMJ and on the Cochrane database, and they revealed important uncertainty. Here's the plot of the meta-analysis from the review, and it included unpublished trials as well as some unpublished trials as well as published reports of trials. And what it shows is the uncertainty is compatible both with an increase in mortality following steroids and a decrease. And clearly, head injury, traumatic brain injury, is a very, very common condition, particularly with the increase in motorcar and other road transport around the world. It's a very, very important issue. So it's actually quite important to find out, even if it's only a 10% increase or a 10% decrease, that's the truth. 10% of a very large number is a very large number. So, both the systematic review and a survey of clinical practice, which showed that some people gave this treatment, other people didn't give it, led to a proposal for a large, publicly funded, it was the MRC in fact, trial. The trial was registered prospectively, and the protocol of the trial was published. So people couldn't come back at the end and say, well, actually, you're looking at an outcome you never intended to outcome. You've actually switched it because one is statistically significant and the other isn't. That's a type of bias which has been demonstrated. And it was published in the Lancet in 2004. And what it shows is that we've been killing patients for over 30 years with this treatment. And interestingly, the point estimate that came from that particular trial was very similar to the point estimate of the Pitts trial in 1980. It's about the sixth down there, which had never been published. So there were clues earlier on that from that, the Pitts trial was, as the collection of trials goes, one of the bigger ones, but it had never been published. Presumably because they thought that even if it was a disappointing result in terms of the point estimate, it wasn't statistically significant increase. So the report of the CRASH trial is exemplary because it refers to current uncertainty and the systematic review of existing evidence and variations which confirm that. It notes that the trial was registered and the protocol published. It sets the new results. The new results are the square down the bottom, okay? And the diamond above it is what was known from the earlier review. The diamond below it is when you put all of it together, including the new results. So it updates the systematic review, and in that way it provides readers with all of the evidence needed for action to prevent thousands of iatrogenic deaths. Too few papers that we are invited to read do that for the reader. Give you a summary of where does this leave the totality of the evidence as assessed using scientific methods. So, coming to an end now. Patients have suffered and died unnecessarily because of a failure to address important uncertainties, like that one I just showed you, biased underreporting of research, and failure to review existing evidence systematically when planning new research. Here's, I said I'd come back to Alessandro again. He said in the same letter, I've had the opportunity to consider from more than one perspective the mismatch between what clinical researchers do and what patients need. I'm a researcher. I have a responsibility for allocating funding for research, and I've had multiple myeloma for the past decade. A few years ago, I stated publicly that several uncertainties I faced at the beginning of my disease were avoidable. An essential component of any new governance strategy would be to bring together all the stakeholders, starting from an analysis of existing and ongoing research produced independently of vested interests. And I'm going to leave you with Alessandro's words because, in essence, that's where I sit where it comes to this issue. And I think the research community has got to do something about it. It won't do enough about it left to itself. It's going to have public pressure from people who say that this situation is indefensible and that the idea that the scientific community can go on implicitly believing that there's no fundamental things wrong with the way they're behaving is just not acceptable in the light of the evidence. Thanks very much. Or comments.
Questions.
Yeah, but there can be comments. I welcome comments. You think I'm barking up some wrong tree.
So I was wondering. So obviously, I agree with you that there's a lot of voice going on, and it's harming people, and should be fixed. If you were to try and fix the system, how would you do it? Would you try and approach researchers and educate them better in trial design and scientific method? Would you try and approach funders to ensure they're not funding trials which are wasteful? or would you try and institute some kind of regulatory body, for example, government or something external to government, and if so, would that need to be international to prevent people just funding overseas, potentially?
Right. Some of, I have got a slide there, but I decided not to put it up because it's our recommendations from this particular paper. But remember, there are 5 papers. All of them have got recommendations. The vast majority target research funders. That's where the rot starts. Also, research regulators as well. They're not doing the job that they should do. And one wonderful example of what a regulator can do and transform a situation is that the Health Research Authority, which is quite a new authority, it was started just over a year ago, announced that from the 30th of September, a positive ethical opinion will only be given to clinical trials that have been registered publicly. And at a stroke, that is going to solve the problem in this country of non-registration. Finding out how to deal with non-publication is very difficult. The most senior professor in this University of Medicine, John Bell, is not wholeheartedly in favor of transparency of research results. He thinks that industry may suffer, and given that he's on the board of several companies, it's not surprising that he thinks that way. And in fact, a letter in the BMJ published earlier this year showed that just from Roche alone, he gets over $400 a year. So there are people who are basically got conflicting interests who are actually against the kind of changes that are needed to do right by patients, particularly the patients that participate in clinical trials. So there are a number of different ways. In the papers that come out on the 8th of January, that's the target date, and I think they will, there'll be a number of recommendations, but I can tell you in advance that most of them are targeted at research funders. Leon.
Very fascinating presentation again. As I said to you, I'm interested in how this translates to the physical sciences because, as I mentioned to you, Sir Paul Nurse, who's the current president of the Royal Society, talks about more research, and this is the emphasis, particularly in the research institution, which has become an industry, is that we must have more research. Now, the aspect of this department, which looks into inorganic chemistry of superconductivity, there have been 100,000 papers on superconductivity, and we still don't know the basic mechanism. So clearly, something has gone seriously wrong with the way the research has been gone into. And you touch on various aspects of this. Picking winners is something which I've talked about to people about before, which immediately you start about talking about picking winners, start to say, oh no, you can't do that. We have to have a completely open mind about research. So somewhere about this picking winners has to be involved in it. But you also talked about non-peer-reviewed papers. And in fact, there's a move towards the ability to publish non-peer review in particular sets of journals. So people know from the very word go that when they're reading a paper, it hasn't been fully peer-reviewed. So they know that certain aspects of it which may be right or may be wrong or whatever. But that gives, it's a fast-track process towards publishing certain types of research. So that type of paper can actually get in. Then you can narrow down the amount of research that you want to do in the peer-reviewed level, I think very substantially. Mm-hmm. And I'm very concerned about the way the research is going. For example, the Crick Institute in London is a £400 million effort, which is supposedly looking into disease research, which is genetically based. This is a machine which is based in central London, which is absolutely the wrong place we would want to pay to put new research in anyway, which whole nurse has got an interest in promoting. Somehow we have to, because there will become an end to the amount of money that in this context, the patient is society. Society, through the Research Council, the Physical Research Council, allocates a certain amount of money, and that has been either growing or as a proportion of GDP has certainly been stable, and it's an absolutely vast amount of money. And somehow we have to get a handle on how to improve outcomes, success in research in the physical sciences. And I think by looking at some of the things that you're doing, meta-reviews of existing research, of which, as I say, in particular areas, you have a vast amount of existing research which you could look at outcomes of. You could have people who specifically look at what the existing outcomes of research has already been and say, right, these are the areas we ought to be looking at.
Mm-hmm. Well, I hope you predict that I would agree with everything you say. I don't know how to do it in physics as a whole, but what I can say is that small particle physics has actually been a shining light to those of us in medicine, because from the 70s onwards, they were actually publishing their preliminary findings in the Ginsberg archive in Stanford. And so people had the opportunity to criticize preliminary reports before they were finalized for the record, as it were. Now, maybe I'm seeing it through rose-tinted spectacles, but that's the way it looked to me when I looked at it, must be 20 years ago now. But there was quite a nice editorial written in a medical journal, in fact, by a guy called Barker Bossell. He works at the University of Maryland. And he proposed that there should be a moratorium on all new research until we found out what we knew already. Then only then should you embark on new data collection. And in the light of the evidence that's available, that is not far-fetched. But can you ever imagine people agreeing to it? No, they won't. Unfortunately.
It strikes me that the funding agencies, if you're going to change the status quo, the peer review process needs to be redesigned, because it tends to be rather incestuous, and the reviewers tend to be handpicked for their closeness to the approach being considered.
I think
taking a wider view is simply not done in the way that you're proposing.
Well, I think you're right. Something that occurred to me as Leon was talking was, I forget the name of the equivalent to the Nobel Prize in mathematics. Someone here will know that. Sorry?
Field medal.
The field medal, okay. So there was a field medalist in Cambridge who put up on the internet a mathematical problem which he hadn't been able to solve, and invited people to help solve it. And within about 20 minutes, actually, it had been solved, with lots of people pouring in with sort of one suggestion after another, and eventually it reached a stable state with a solution to the problem that he'd put up there. Now, I don't know if field medalists are part of crowds, but this business of the wisdom of crowds and getting lots of eyes looking at a problem to see what comes out of that process, not necessarily being hidebound to do what comes out, but nevertheless to take it into account. There must be better ways of getting ideas out than depending, as you say, on some very incestuous funding panels. Everyone looking out for their turn to receive the bounty that had been created by people shaking tins in the forecourt of Paddington Station and other stations. It really isn't good enough. And yet there's a tremendous amount of, I would say, complacency. I mean, I'm a fellow of the Academy of Medical Sciences, have been for 10 years or so. I regard that organization as quite unable to bring itself to criticize some of the things that are wrong with science, medical science in this country. Now, that's a very bad sign when a very powerful institution can't criticize what, in all conscience, must be criticized on behalf of the public. So, money makes an awful lot of difference. I don't know whether the Crick Institute is a vanity project, but clearly there are people who want to leave their names to having created a very large pile of glass and concrete. I don't know what the solution is. I'm not part of that cabal. That's why my main interest these days is to try and help the public to understand that this is a problem, and it's basically they who are being let down. After all, they pay for the research. They pay for it through their taxes directly. They pay through it either because of direct use of the tax income or because charities are tax exempt, and therefore the rest of us have to pay more in taxes to cover that. And they pay for it in terms of devices and drugs because we end up buying the blooming things and the public pays for that. So in essence, the public ends up paying for this inefficiency. And it's very poor return on their investment.
Or they pay through being on the receiving end of all research.
Exactly. Well reminded. I mean, I should have come out with that. It's so good to hear that you came out with it. Thank you. Field medalist up there.
I'm actually interested in the point you raised just now and linking that to the point you made about John Bell, because I agree, well, I struggle with the idea of transparency because I agree that it's necessary, and that links with the sort of crowdsourcing example you just gave as well. I believe it's necessary, but at the same time, and I think this, I mean, regardless of Professor Bell's motivations, there is a need to ensure that companies do their research and their commercialisation in the UK. I think
Why? Just a matter of interest.
Well, because it generates government revenue, which then funds NHS, the NHS, which is 65% of our GDP. It's entirely necessary to generate more tax revenue.
Well, do you think that, I mean, the other great industry we have is armaments, isn't it? Armaments. Okay, so you can defend industries that are contributing to the gross domestic product, as it were, regardless of whether they're making manacles or cluster bombs and so on. You can also defend them on the basis of they hide half their results and charge us the earth for drugs promoted on the basis of the half that isn't hidden. But I don't think we ought to do that. I really don't. I think we ought to be concerned about employment levels in Greenford or wherever it is. GSK has decided to be open about this. So why not other drug companies? If GSK can do it, why not other drug companies?
I mean, GSK have promised to do it, but I haven't really seen anything.
Oh, haven't you? Oh, I have. It's remarkable what they have both done and promised to do. They certainly signed up to alltrials.net.
Right.
Now, why doesn't the Academy of Medical Sciences do that?
But then, because I worked with clinicaltrials.gov in the US, and that was shocking.
Sorry, you say again?
I worked with clinicaltrials.gov in the US and found it shocking how inconsistently trials are reported in
Yes.
terms of how much is reported.
Yes.
There were almost no results, and the results are mandatory and supposed to be posted within 1 year of completion of trials.
Yep.
There was literally a handful of trials with results,
Yep.
and people weren't using it. It was completely inaccessible to patients,
Yeah.
who were the people that the database was designed for. So it's
You're absolutely right. It is shocking, isn't it? So what are we going to do about it? Are we going to acquiesce in people who want to actually maintain the status quo and say that there's intellectual property which we've got to think about? Well, of course there is. The patent system is there to actually protect intellectual property, but not at the expense of patients suffering and sometimes dying because of hidden data. That is unacceptable. Anyway, I don't know whether you're a medical graduate, but as a medical graduate, my first responsibilities are to patients. Okay, there are secondary responsibilities that I might have to shareholders of companies that make profits out of medical products, but the primary responsibility is to patients. And if you can actually be shown to be harming patients by things that are accepted as reasonable characteristics of the status quo, then I just hope you get to sleep at night all right.
What are you saying as the problem about publishing this is trials, this is
Yeah.
commercial trials? What are you saying is the prejudice to the company that might be?
I mean, it's more just a disincentive. I agree it's not good because I feel like pharmaceutical companies in general have too much power. And that if they have the power to say, if you make me publish every trial that I do, then I'm just going to go do my trials in Belgium. And then we lose a whole lot of revenue and we lose that use of our system.
So it's playing off one regime against another.
In a sense, yeah.
So GSK is a global company. I'm quite certain must have trial sites in Belgium and other places as well. But the thing is that let me go back to a meeting must have been about 4 years ago, organized by the Academy of Medical Sciences. And the title of the meeting was Experimental Medical Science. And the idea was it was addressing this issue of the translation from basic to applied research. And I didn't know anything much about this, so I thought I'd gone along and hear about it. And there were two people, both of them from industry, but giving separate presentations, and they produced the same data from a data company called CMR International. It collects statistics of what drug companies are up to, failure rates of type 1 of phase 1 studies and phase 2 studies and so on. And what they showed was that phase 2 studies, which are basically the first ones in they're increasingly comparative now, but after the phase 1 where you're trying to find out whether the drug is so toxic that it's not going to work, like those poor boys in Northwick Park who had cytokine storms. Do you remember that thing, TGN 1412? 6 volunteer researchers ending up in intensive care. Some of them have lost toes and fingers, and their immune system is probably shot for a good part of their life now. And it was later shown that there was evidence already available that should have warned of that happening. Now, I'm talking about the phase 2 studies, which are starting to be used, the drug's starting to be used in patients at this point. And what they showed was a very high failure rate of phase 2 studies, and that the failure rate was increasing over time. So I asked the question, is there any possibility that this high failure rate reflects the fact that phase 1 studies that have had disappointing results aren't getting published? And both of these people said that, yes, they thought that was part of the problem. Now, that was in the morning session. In the afternoon session, there was a speaker from Quintiles, which is a contract research organization that does clinical trials for manufacturers of drugs. And without reference to the morning discussion, the person who was presenting said, something that really frustrates us is that we will be asked by a company to design and run a trial for them. And we know it's going up a blind alley because we've been up the blind alley with another company previously, but we can't tell them that. So there's actually built-in inefficiency to the discovery process because of this secrecy. Science is not meant to be secret if you want it to work efficiently. At the moment, we've got actually a very poor track record over the last 30 years of producing. I mean, there have been the antiretroviral drugs, for example, for AIDS, a tremendously effective program of research for what was previously a lethal disease. But quite frankly, compared to the amount of investment that's gone into medical research and the development of new treatments, it's pretty poor return on investment, what we've had. And when you start to look at the way that the system works, it's really not surprising. If you hide the evidence that ought to be being taken into account to embark on a new line of research, then the people coming afterwards will do unnecessary trials, finding that they're up the same blind alley as you have found yourself before. It's not, in other words, it doesn't even make sense economically, let alone in terms of the interests of patients and the public, I think.
I think we can take one more, and then Sir Chalmers will stay around probably for a couple of minutes after that.
Are there two hands up there? There are two hands. Can we take those two, given that they're both up?
Firstly, I agree with what you've said today. It's quite shocking, your actual data. But from what I've been taught and from what I've been taught, how big pharmaceutical companies approach phase clinical trials is that before they actually put a drug into clinical trials, because they cost so much, they only do it if they're pretty certain that it's going to get to market. So obviously what you've shown us is that there's a lack of, they don't know some of this information.
One of those cohorts that I showed you from the Nature article is in fact a GSK cohort.
Right, okay. I was wondering, is it with all pharmaceutical companies, obviously, because obviously they're built on the basis of profit, and obviously clinical trials are incredibly expensive. Is it for the whole pharmaceutical industry, or is it just for a couple of,
I'd say the whole system was wrong, and I'm on record as saying I don't blame the companies. Why should they be expected to do anything that they can get away with within the law to serve their shareholders' interests? The people I blame are the people of my profession who collude with them. They couldn't do what they're doing if it wasn't the case that there are doctors who are prepared to go along with putting shareholders before patients. They couldn't do it. So there's a real problem of refocusing the attention on my profession and the way it's behaving. Does that address your question in a way?
Well, it kind of does, but I just don't understand why pharmaceutical companies would actually invest in these particular drugs, because even if they do get to market and all these side effects, all these patients do start to die. For example, if Avandia of GSK, in my second year, GSK came to my university and said, right guys, if we want to make a drug, from the start to finish, this is what we do, this is how you do it. And literally 6 months down the line, all these side effects started coming out, and GSK had to pay out tons and tons of money in lawsuits. I don't understand why, in terms of even business, not just science, why a big pharmaceutical company would actually do that without actually knowing anything, because there is this very strong possibility that without the overall knowledge, that they could actually lose a lot of money.
Well, I mean, one of the things to bear in mind is that a 1 in 2 chance of a new treatment at the phase 3 stage being shown to be better than an existing treatment is not bad.
No, it's good.
And if it's an important treatment for an important condition, that's fine. But in fact, quite a lot of the profits are sought now by extending the definition of the patients who should receive a drug that's already available. It's called disease mongering. Have you come across that term? There's a wonderful video put out by The Onion on a spoof drug called Despondex for the incurably happy. And it shows how basically you might get the same effect from doing no exercise and having junk food and so on. But in fact, people really do need to have Despondex. It spoofs the disease-mongering trend very effectively. And in fact, there's now, the first one was in Dartmouth in New Hampshire a couple of months ago. It's the first international conference on overtreatment. And that's one of the ways in which you can actually sustain the profits, even if the drugs aren't very good. So, you know, there are all sorts of ways which are still within the law. I mean, they're just for example, GSK, under its previous chief executive, the current one, Andrew Whitty, I think is a hero. The previous one, Jean-Pierre Garnier, was an absolutely disgraceful man. It was on his watch that the antidepressant drug, which they were marketing for adolescents in particular, they actually suppressed the evidence of suicidal ideation that they seemed to promote. And perhaps some suicides actually occurred of children who had been put on this. And they suppressed that, and they were taken to court by Elliot Spitzer, who was the Attorney General of New York State, and were fined a very large amount of money. In fact, they've been fined since then. But I actually give the current leadership in GSK a great deal of credit for saying we really got into an awful lot of bad odor with people looking at what we were doing. We've decided to change, and I think they're wholehearted about that. 2 weeks ago, I co-authored an editorial in the Lancet with the most senior doctor in GSK. You know, I'm seen as a bit of a sort of iconoclast. So some people were very surprised that we were able to write something together. But if you're interested in seeing how he was able to, in fact, he did the first draft of the editorial, and he was already in the same position I was in when I got the draft to add my bit to. So I think that one's got to encourage those people within industry who are trying to change this. But you mustn't forget the people within academia who are not working on industry-funded studies, but who too often are guilty of the same kinds of misbehavior. So it's not as if, as I showed with that graph, it's not as if people working for industry, the bad guys, and the people working, as it were, as independent academics are squeaky clean. It's not that at all. They're very similar. There's someone up there.
I think it was mentioned briefly in another question, and also in Ben Goldacre's book, which you showed.
Mm-hmm.
At one point in America, the FDA tried to mandate that all trials be published. However, the drug companies which signed on to it actually ignored it in a large number of cases because even fairly large fines were negligible compared to their profit. How would you ensure that any companies which signed up to all trials actually follow through?
Public shaming. That's what the campaign is going to move to. It's going to actually produce lists of people who haven't lived up to what they should have lived up to. And they'll include the names of the companies, the names of the chief investigators of the trials concerned, the names of the institutions where they... that's the only thing that's going to make any sort of difference at all. It's like a good food guide, basically. If you want your restaurant to have a decent business, then you do a decent job. And you get credit for it in Michelin 3 stars or whatever it is. It should be the same for people doing trials. There should be a star system with beyond the pale being the bottom and wonderfully publicly spirited and productive with important new drugs at the other end.
Can I comment on that? Sorry.
Yeah, as long as the chairman agrees, I don't mind.
Jeremy?
Yeah, but shortly, please.
Really quick. So, no, that's really interesting, the public shaming thing, because that worked beautifully for Starbucks and the tax evasion, and there was a real public boycott of that. But I don't think it will work for drugs. I think patient advocacy groups, getting those people involved, maybe that would work. But if I'm ill, I don't care if my drugs are registered on clinicaltrials.gov or not, or all trials even. It doesn't make a difference to me. I'm taking my drugs regardless of whether or not I love the company.
Yeah, you can't be sure that they'll actually work very well.
If you've not got integrity, it's like a trial.
Let me put a response to you. Do you think it's worth giving it a try?
Pardon?
Do you think it's worth giving it a try?
Yeah, of course.
Good. Okay. There you are. We've got a solution.
Okay, so before I go, there are 2 announcements. I think there should be a refreshment first, including wine. And the second one is that next week we are hosting Professor Sir John Ball. He's going to talk on what can mathematics say about liquid crystals. So if you're interested, please join us for that. And thank you so much for coming, sir.
Not at all.
It was
Thank you
great
for the
time.
invitation.